Good days for total everyone. We come from Good Night, and today we want to present about the assignment 2. Before we start our presentation, let me introduce my teammates who are Won Zeng Cheng, Nuifa Sofia binti Hamidi, Mohammad Ali Mikhail bin Mohammad Anwar, and also Lailatu Akmal Nisa binti Mohammad Jesni. So, the industrial field that we chose is agricultural field. We think that this field is very important and you must pay attention to this field because agricultural field plays a main role for our human and Malaysia. Our country also has high performance in this field because its strategic location. So before we start our presentation, let me introduce some report contents. So first one is industrial involved in agricultural field. Second is chosen industrial product. Third is process involved in industry. Fourth is advantages or disadvantages of conventional and greenhouse processor. Fifth is issue related to conventional process. Sixth is impact of greenhouse processes. And also the seventh, which is the last one, is the related reference within 5 years. So the first part is me to present.
Good days for total everyone. I'm Won Zeng Cheng. Industry that we chose, which is involved in agricultural field, is Sd Guthrie Berhad. Why we choose Sd Guthrie Berhad as our industry that involved in agricultural field? This is because Sd Guthrie Berhad is our large-scale local company. And our chosen industrial product which is produced from Sd Guthrie Berhad is bio-based fertilizer. Why we choose bio-based fertilizer as our industrial product? This is because Malaysia has high performance in plantation due to its geology. So now I will present about the process involved in industry. So now, Sindabi, also known as Sd Guthrie Berhad, always focuses on its bio-based fertilizers through its innovative practices in the palm oil industry. And now I will explain about the process unit involved in their making of bio-based fertilizer. So first one is combusting units. This unit will be utilize the palm oil byproducts such as inner kernel oil palm fruit. And next one is about the fermentation and processing units. This unit will be convert the palm oil into the bio-based fertilizer by a process of burning to obtain ash, and this ash will be used to do the fermentation. So the third process unit involved in their making of bio-based fertilizer is quality control and R&D unit. This unit is to ensure fertilizer is in environmental standards. And the last one is distribution and application unit. This unit is to package the bio-based fertilizer and supporting large-scale plantations with eco-friendly fertilizers. After we discuss about these units that they make, so we will categorize them as upstream, midstream, and downstream. For upstream is combusting units. For midstream are fermentation and processing units and quality control and R&D units. For the downstream is distribution and application units. Here's the detailed process that met by upstream. First, they will collect the organic material, and also that they will undergo the composting and do the aeration and temperature control. And the last one, they will do the maturation. And maturation product will be transferred to midstream, which is fermentation and processing unit. And inside the fermentation and processing unit, they will produce the biostimulants. After that, they will undergo the microbial inoculants. And also, they will undergo the mechanical processing. And the last one, they will undergo the chemical processing. After we do the chemical processing, the product which is undergoes the chemical processing will be transferred to midstream, which is quality control and R&D unit. Inside the quality control and R&D units, we will undergo the fermentation and combusting technique towards the product. After that, we will do the optimization of bio-based fertilizer properties. Next one, we will control the temperature and moisture in combusting. And the last one, we will do the microbial contamination prevention. And the product will be transferred to the downstream, which is the distribution and application units. In distribution and application unit, it will undergo the storage facilities and cost and time efficiency, optimal application timing, and also the soil health monitoring. So here are the detailed explanation for this process that occur in upstream, which is the combusting unit. For first one is the process of correction of organic material. Organic materials like EFB, which is known as empty fruit branch, and other residues from the palm oil are distinguished via milling process. Next process is combusting process. Materials are combusted through a biocontrol process where microorganisms break down the organic matter into humus-like material, and the biocontrol process is by using enzyme. And the next one is aeration and temperature control. Proper aeration is maintained in the combusting unit and ensuring the oxygen availability to microorganisms, and controlling the temperature is around 50 to 17 degrees to speed up the decomposition. And the last one is maturation process. Compost is allowed to mature and become valuable bio-based fertilizer, which is ready for application to aspect of plantation and harvesting. And next are the detailed explanation for process which is occur in midstream, fermentation, and processing unit. For first process is production of biostimulants. Fermentation uses to produce the biostimulants from organic material, which is the compound that enhance the plant growth. Next one is microbial inoculants. Biostimulants such as the nitrogen-fixing bacteria that help plants by improving the nutrient availability, especially nitrogen. Next one is mechanical processing. This process will be involve the shredding, crushing, or grinding organic waste material into smaller pieces to accelerate that decomposition during fermentation. And the last one is chemical processing. So in some cases, processing unit may involve the application of enzyme to speed up the decomposition, like neutralizing the acid or enhance the microbial activity for effective fermentation. Midstream, quality control, and R&D also have some processes involved in this unit. Here is the detailed explanation. First one is the fermentation and composting techniques. We will do some researches into fermentation process to ensure that the breakdown of organic material as efficient as possible. Next one is optimization of bio-based fertilizer properties. We will do some research which is focused on refining the nutrient profile and slow release properties of bio-based fertilizer based on the condition. Next one is temperature and moisture control in composting. So during fermentation, temperature and moisture levels are monitored to ensure that optimal microbial activity and the proper breakdown of organic matter. This because that some microorganisms only will be do the efficiency work at optimum temperature. And the last one is microbial contamination prevention. Fermentation processes also require the amplification of beneficial microorganisms, which is the cell division. And also the last one, downstream. distribution and application units. These have some process involved in these units. First is the storage facilities. Once we produce the bio-based fertilizer, the fertilizers are stored in storage silos. Next one is cost and time efficiency. The distribution process is optimized to reduce the transportation costs and ensure that fertilizer reach the plantation fields in a timely manner. Next one is optimal application timing. The timing of fertilizer application is crucial to maximizing its benefits. The last one is the soil health monitoring. Fertilizer application is often combined with regular soil health monitoring to ensure that the fertility of the soil is continuously improved. Here is the overview for upstream, midstream, and downstream processor. Under the composting units, we will undergo the correction of organic material, composting, aeration, temperature control, and also maturation. Under the fermentation processing units, we will start on the production of biostimulants, microbial inoculant, mechanical processing, and also the chemical processing. And under the quality control and R&D units, we will undergo the fermentation and composting technique, optimization of bio-based fertilizer properties, temperature and moisture control in composting, and also microbial contamination preventions. And the last one, under the downstream, we will undergo the storage facilities, cost and time efficiency, optimal application timing, and also the soil health monitoring. So this is the overview for the upstream, midstream, and downstream and how they work. So as we know the SIMDABI that making the bio-based fertilizer process, we also need to understand the equipment used for this process. So for first one is the composting unit. The equipment used is oil filter machine, treasure, digester, oil press machine, and also the belt conveyor. Here is the image for the oil filter machine. Next one is fermentation and processing units, which is the equipment required is fermentation tanks, boiler, and steam generators. Next one, for the quality control and R&D units. Equipment used is pH meter, moisture analyzer, spectrophotometer to measure that the biofertilizer is in environmental standard. Here's the image for the pH meter. Last one is distribution and application unit. Equipment used are automatic weighing and baking machine, valve bag, filling machine, and also the foam fill seal machine. Here is the image for the automatic weighing and bagging machine.
So the second part is my teammate Nur Ifa Sofia Binti Hamidi to present. So before she present, let me describe her part, which is the advantages and disadvantages of conventional and greenhouse process of biofertilizer.
Everyone, today I will explore the advantages of two important approaches in biofertilizer production: the conventional route and the greenhouse. Both methods play a very significant role in agriculture. They serve different purposes and come with unique benefits. Okay, let's start with the conventional route. This approach is characterized by its established method. The processes and techniques in the conventional route are very well documented and widely understood. This ensures consistent and reliable production outcomes. The second one is the wide range of products. Conventional processes support the production of a variety of biofertilizer, including nitrogen fixing and phosphate solubilizing types. This variety caters to the specific needs of different crops and soil conditions. And the third one is the cost-effective at scale. Due to economies of scale, the conventional route allows for lower production costs. This makes it viable for large-scale agriculture operation where cost efficiency is crucial. Okay, next, let's discuss the green route, which emphasizes sustainability and environmental care. Its advantage includes eco-friendliness. The green route emphasizes sustainable practices, reducing carbon footprints and waste. It uses renewable resources and biological methods, making it an environmentally responsible choice. And for the second one, it improves soil health by avoiding synthetic carriers. The green route promotes organic and biodegradable alternatives. This enhances soil health and ensures long-term agricultural productivity. And the third one is low energy input. Unlike the conventional approach, the green route minimizes energy uses by relying on natural and sustainable production methods. We're going to delve into the disadvantages. Understanding this, let's begin with the conventional route. Despite its efficiency and the scalability, it has some significant drawbacks. The first one is the high energy consumption. This approach relies on energy-intensive equipment for sterilization, drying, and packaging. As a result, it consumes a significant amount of energy, contributing to higher production costs. The second one is the environmental impact. The conventional process generates more waste and may contribute to greenhouse gas emissions. This can negatively affect the environment and counter the purpose of eco-friendly agriculture. The third one is the dependency on chemical additives. Synthetic carriers and stabilizers are often required in the conventional route. This can degrade soil quality over time, affecting long-term soil health and productivity. Next, let's discuss the green route, which, despite its eco-friendly benefits, also faces challenges. The first one is the initial cost and infrastructure. Adopting sustainable processes requires significant investment in new technology and infrastructure. This can be a barrier for small-scale farmers and producers with limited resources. And the second one is the scaling challenges. Decentralized production method in the green route can struggle to meet the demands of large-scale agriculture. This may limit its application in regions requiring high volumes of biofertilizer. And the last one is the longer development time. Processes like natural fermentation often take more time compared to the industrial techniques. This lower production cycle and can delay the availability of biofertilizer for farmers. That's all from me. Thank you.
So the second part is my though. So the third part is my teammate Muhammad Ariel Mikhail bin Muhammad Anwar to present.
So now for my part, I will explain on the issues related to conventional chemical process in biofertilizer. So based on our findings, we have concluded that we have found 10 issues in biofertilizer. The first one is energy intensive processes, which is many conventional chemical methods require high temperatures and leading to significant energy consumption. So with this reliance on non-renewable energy sources increases the carbon footprint. For the next issue is environmental pollution, which is byproducts or waste from chemical processes may contain harmful chemicals that can contaminate soil, water and air. With this excessive use of chemical fertilizers or improperly processed biofertilizers, that can lead to nutrient leaching and eutrophication in water bodies. For the third one is resource depletion. Conventional processes often depend on finite resources like natural gas, for example like ammonia synthesis, or mine minerals such as phosphates. And over time, the availability of these raw materials will be diminished or reduced, making the processes less sustainable. And for the next issue is loss of microbiability. That harsh chemical treatments used in biofertilizer production may kill or reduce the effectiveness of beneficial microorganisms. and these organisms are essential for improving soil health and plant growth. And the fifth issue is cost inefficiencies. The complexity and energy demands of chemical processes can make biofertilizer production become more costly, and these higher costs may discourage farmers from adopting biofertilizers over traditional chemical fertilizers. The next issue is quality and consistency issues, which is chemical processes might not adequately support the diverse needs of different soil types and crops, and variability in the quality of biofertilizers can reduce their effectiveness in the field. And for the next issue is over-dependence on additives. Some conventional processes require chemical additives to stabilize the product or enhance nutrient content, and with these additives may have unintended long-term effects on soil and plant ecosystems. And the next issue is inefficient use of raw materials. Conventional methods may not efficiently utilize organic waste or agricultural residues, which are common feedstocks for biofertilizers, and this inefficiency can lead to resource wastage and missed opportunities for circular economy practices. Another issue is regulatory and safety concerns. Handling and processing of chemicals in biofertilizer production can pose safety risks to workers and the surrounding community, and the regulatory compliance with environmental standards can be challenging and costly. And the final issue that related to conventional chemical process in biofertilizers is limited stability, which is many traditional chemical processes are designed for large-scale industrial settings, making them unsuitable for small or medium-scale producers. And with that, this limits the accessibility of biofertilizers to smallholder farmers. That's all from me. Thank you.
So the last part is my teammate Lalatu Akma Nisa Bindi Muhammad Jasni to present her part.
Hi, my name is Laila and I will present about the impact of green process. In this slide, there are four impacts has been stated, which is environmental impact, economic impact, social impact, and technological impact. So before I go one by one with the impact of the green root process, let me explain about the green root process first. So, what is green root process? Green root process is basically refers to environment sustainable practices and technologies which aim to improve the agricultural productivity while minimizing environmental degradation. So, these practices are oftenly include organic farming, use of renewable energy, integrated pest management, sustainable water use, and soil health improvement strategies. So, let's go through with the impact one by one. So, first is environmental impact. In this environmental impact, reduce carbon footprint, renewable energy, and reduce reliance on chemical fertilizers and pesticides, which helps to lower the greenhouse gas emissions. Next is biodiversity preservation, crop rotation, and organic pest control, which is these practices can support ecosystem health and reduce the loss of beneficial species. Next is soil health improvement. Green process enhance soil fertility, such as through organic composting, reducing erosion, and maintaining the soil's natural structure. Next is economic impact. In this economic impact, cost reduction, market advantage, and risk mitigation. In the cost reduction, reducing dependence on chemical inputs and utilizing locally available organic materials, which means farmers can save their costs due to the available organic material. Next is market advantage, which is demand of organic and sustainable product that might be increased globally, so that this will allowing the farmers to achieve their premium price of their product. Next is risk mitigation, which improve resilience to climate change, and reducing the economic risk. In this case, if the environment sustainable practices be practices, and this can lead to prevent the extreme weather event. Next is social impact. In this social impact, first is improve public health, empower communities, and enhance livelihood. In the improve public health, which reduction in chemical pesticide will help to residues in food contributes to better consumer health. Next is empowered communities. Green agriculture are oftenly involves local knowledge and community participation, fostering cooperative farming system. And next is enhanced livelihoods, which sustainable farming practices will lead to stabilize the incomes due to improve the soil productivity and higher market value for green products. Last but not least is technological impact. In this technological impact is innovation in farming techniques and data-driven agriculture. For the innovation in farming techniques, adoption of green technologies like drip irrigation for fruits and vegetables, renewable energy-powered machinery, and bio-based pest control can help to enhance the efficiency. Next is data-driven agriculture. Integration of technology in monitoring resource usage helps in making informed decisions that leading to optimize the process. That's all for my part, and I will pass the next part to the next presenter.
So the last one, this is our reference within the 5 years. And that's all from us. Thank you.